Hi, I'm Benny D, and in this video we're going to look at how to find the volume of cones. Now, a cone is actually just a special type of pyramid, okay? Which you might not think that it looks like that, but what it is we have a circle at the bottom, okay, and then we've got edges that all meet up at a point somewhere up the top, okay? So a point up the top, and we've got a circular base. Okay, so if you've seen my video on how to find the volume of pyramids, you'll know that all we need to do to find the volume is find the area of the base, times it by the height of our pyramid, okay, or in this case our height of our cone, and divide it by 3. And again, most of the time we think of cones, we think of like ice cream cones, and we used to, if we're looking at it from top down, we used to think about a cone whose point comes to the middle of our circle. Okay, it's lined up with the middle of our circle, but it doesn't have to be. Okay, it could be over at the side here, could be over here, could actually be right at the edge. Okay, it actually doesn't matter at all for our formula for the volume. Okay, as long as it comes down to a point, it's basically just finding the area of our prism, or in this case, area of a volume of a cylinder, and then dividing it by 3. So we need to go for the area of our base. Now, the difference for this is we've got a circle. So remember, the formula for the area of our circle from previous videos is pi r squared times by the height of our cone divided by 3. And remember, it wouldn't matter if I drawn my cone upside down like it is an ice cream cone and we came down like that. Wouldn't matter, we'd still just take our height down there. Okay, so for this example, let's take the radius to be 3 centimeters. We're going to take our height. Now, this is really important. Okay, if we think of a cone side on, we're actually only going to see a triangle because the circle is down the bottom. So I've drawn off camera there. So if we think of our cone here, side on. Okay, if I was to draw this one side on, okay, all we see is actually a triangle, because the circular base is this part here. So our height, we've got to be careful, just like with our pyramids, it's not this slant height, it's this height that's perpendicular or at right angles to the base. So we've got to be careful there. So I'm going to call that height, and this one 5 centimeters. Okay, so we're going to find then our volume, okay, is pi, which we're using at 3.14, times our radius, which is 3 squared, times our height, which is 5, and then we're going to divide it by 3. Okay, so we're going to say that volume equals 3.14 times by 3 times by 3 times by 5 divided by 3. Nifty little trick here is if one of these numbers is actually exactly 3, it can cancel out with that 3 at the end to make our calculation a little bit easier. So now we've got 3 times 5 is 15. Well, 15 times 3 is going to be 45, but we need to be a little bit more, so we're going to approximate our answer to be 48 centimeters cubed. Okay? No, it's not exactly that. Use a calculator, make sure you're right. Okay? But essentially, we're doing exactly the same thing as what we did for our pyramids. The only difference with a cone is the base is actually a circle. So just like any other pyramid, we think of it like a prism first, or in this case, a cylinder. We find the area of the base, times it by the height, divided by 3. You see, there's some really nice patterns in maths, and this is one of them, where our formulas are all very, very similar.